Good afternoon, advanced algebra class. I hope you are doing fantastic. This is our last notes for quarter 2, so it's pretty exciting. We are wrapping up the notes portion of this quarter, and after this we're basically going to be reviewing for a test, reviewing for the final exam, and then you guys will be shifting to another class and coming back to advanced algebra 4th quarter. So we have basically been talking in chapter 2 about quadratic equations. So that simply means obviously an equation with an x squared in it. And we've been learning how to graph various different formats of quadratic equations, as well as learning several methods for solving quadratic equations. Solving by factoring, solving by square roots, solving by completing the square. Now we're going to talk about one final method. I like this method as a backup method. I never use this method first because there's a fair amount of computations involved. But the cool thing about the method we're learning today, the quadratic formula, is that it will work in any occasion. There are no restrictions on when you can and cannot use the quadratic formula. So first off, let's go ahead and put the quadratic formula on the board. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative b plus or minus the square root of b squared minus 4ac all over 2a. So I do have kind of a silly story that I usually tell in class when we're memorizing this formula. Given that we're probably still in distance learning when you're doing this, you can of course just look at your notes to see what the formula is. But when you use this in subsequent math classes when you're learning in person, this is one of these things that you're expected to memorize and just know. So I like to make up a story about someone named Bill or Bob or Ben, something that starts with a B, going to a party. So I say that Ben was negative because he couldn't decide should he or should he not go to the radical party. If he didn't go, he would be square and he would miss out on the 4 awesome cakes. But the party would not be over until 2 a.m. and he had a test in Mrs. Turner's class the next day. So that's my little story. It's a lot more fun in person. I have somebody try to repeat it after me, and then I have another person try until we all have it down. But it's just like a little tip for helping to memorize it. All right, so let's see what this means. This means that we can solve for x if our equation is ax squared plus bx plus c equals 0. So you do need to have the equation set equal to 0 to do this. All right, so let's do example 1. Example 1 is 3x squared minus 4x minus 9 equals 0. Our a is 3, our b is negative 4, and our c is negative 9. And then we literally just plug this into the appropriate spot in our formula. So we're going to have positive 4 plus or minus the square root of 16 minus 4 times 3 times negative 9 all over 6. Now, the most important error to look for when you're solving is inside the radical sign. We're going to talk about that in a minute. It's actually the name for the number that you come up with. Inside the radical is called the discriminant. But if there's 2 negatives, we're taking a negative times a negative, which will make a positive. So this ends up being 4 plus or minus the square root of 124 all over 6. If we do a factor tree for 124, we can break it down into 2 times 62 and 2 times 31. So to simplify this, we need to show the number underneath the radical sign in factored form. 2 times 2 times 31 all over 6. We take out a pair of 2's, so we have 4 plus or minus 2 radical 31 over 6. And then don't forget, this can be simplified one step further by dividing everything by 2. So I'm going to get 2 plus or minus radical 31 over 3. So this is fairly labor intensive, but this is a problem that we could not have solved by factoring. Something that I would like you to note is that the number inside the radical was positive, and we ended up with two irrational solutions. So I'm going to make a little note of that here. If the number inside the radical is positive, we end up with two irrational solutions. And again, it's irrational because we have this square root of 31, which is a number that goes on forever. And this is a chart that we're keeping track of with regard to the discriminant. So if you can write that down, that would be great. So one possibility is that our discriminant is positive, which does result in two irrational solutions. All right, let's go ahead and take a look at another possibility. So let's do example number 2. All right, example number 2, we've got 3x squared minus 2x plus 7 equals 0. Again, we have an a of 3, a b of negative 2, and a c of 7. So we're going to solve this by plugging in everything we have. X equals 2 plus or minus the square root of 4 minus 4 times 3 times 7 all over 6. Now 4 times 3 is 12, 12 times, 4 times 3 is 12, 12 times 7, I feel like, oh, got it, is 84. So we're going to have 4 minus 84, which is the square root of negative 80 over 6. Notice now that our discriminant, the number underneath the radical, is negative. So this is going to affect what our kind of solution we would have. Let's do a factor tree for 80. 80 is 2 times 40, which is 2 times 20, which is 2 times 10, which is 2 times 5. So x is going to be 2 plus or minus radical. It looks like I have 4 2's and a 5 all over 6. So I'm going to take out 2 2's. X equals 2 plus or minus 4. And then I have an I because there's also a negative 1 in here. 4i times radical 5 over 6. And then I want to simplify that by dividing everything by 2, so I've got 1 plus or minus 2i radical 5 over 3. Now in this case, notice that our discriminant, the number underneath the radical is negative, and I have an imaginary solution. So if our discriminant is negative, I'm going to have 2 imaginary solutions. And up above here where I put 2 irrational, let's just call it 2 real number solutions. Real numbers include rational and irrational. It could be when your discriminant is positive that you end up with 2 rational solutions. So it would be most accurate to say that you're going to end up with 2 real number solutions if your discriminant is positive. Okay, so we've talked about what happens when the discriminant is positive. We've talked about what happens when the discriminant is negative. Let's look at what happens when the discriminant is 0. So this is example number 3. 16x squared plus 8x plus 1 equals 0. Again, we want to identify A, B, and C. So A is 16, B is 8, and C is 1. And then we're going to set x equal to this function here. So we've got negative 8 plus or minus the square root of 64 minus 4 times 16 times 1 all over 2 times 16. Now 4 times 16 is 64. So we've got negative 8 plus or minus the square root of 0 over 32. Notice in this case the square root of 0 is just 0. So this just becomes negative 8 over 32 or negative 1/4. So if your discriminant is 0, this other piece just goes away and we just end up with negative b over 2a. We just end up with one solution. So our x is negative 4. So when the negative 1/4 in this case. So when the discriminant is 0, you end up with one real number solution. Now, I did in my original notes that I typically do, I do more examples showing that with the discriminant, but we've kind of done it as we went this time, so I think we're covered, and we'll just go over any additional details we need during our Zoom session. Thanks, guys. Bye.